Um, my understanding of maybe say the prefix is that it's like being pre-established to yourself that say that I already pre-established that app is in our system, that once it's in our system you can sort of like use this existing data to actually form your remaining data per se. Maybe sometime it's like forming the apple, and sometimes maybe your pre-established is just the ap, and then you can add a e and you will form the ape word. So the pre-established data for yourself to actually abuse it to actually form your remaining words, that's for the prefix tree. So in terms of like the operations, how it's actually going to get conducted is you have a root over here, cool. So now they want to actually insert the data, maybe say apple. So we don't have like anything yet, so we're going to start off with producing the a, producing the p, and then the l, and then followed by the e. And for a word like this, like a singular word, at the endpoint you got to mark it, circle it. So if we were to call it that operation z is about creating all the alphabets, and that once we reach until the end of the word, what we actually do is to actually operation y, making sure that we circle the end of maybe say it as being a word, or rather it's like circling the alphabet to mark it as we have finished conducting the word. And then if we were to actually search for maybe say apple, it will search a p p l e, and it's going to search for operation y also. It's going to make sure that it's actually circling to make sure that for search, this is for search and insert, it goes by the same operation of z and y, where it goes through all the alphabet and making sure that it is being circled. And now we search for app. So here's the interesting thing, is that it's gonna be marked as false. Why is that? It's because that it's gonna go through a p p, and it's gonna try to search for the operation y circle. Is there a circle? There's no circle, so it will be therefore be marked as being false. But if there's like a circle, it obviously is a word, and then it will return true. But for this case, obviously it's the entirety of like the apple, so it will mark as like false. But what if like on the opposite end, the opposite of like maybe say search, is that we, so say for search is very much of like operation w, but maybe say you do this start with, it is like the operation x, where operation x is that saying that is that the app. That's all I'm asking. I'm not asking you if it's like a word search. So operation w is like, is the difference is that it does like conduct of like whether there's like a operation y that's being conducted or not. But for operation x, it doesn't care whether there's like a operation y or not. And so with this, you start with, when you do the operation x, it's gonna be marked as like being true to the data. And then now you go on to actually do the insert ape. So what's gonna actually happen is this, is that you go through the A, you go through like you can have like this operation of AND where you actually oh, I need to create a new word. Okay, I need to create A, I need to create P, I need to create E. Like this one will be under operation AND. But obviously it's very inefficient to like recreate, because the reason of like prefix tree is that it's gonna use like the pre-established data as such. So like this whole thing is like a pre-established data. So in fact, instead of like operation AND, it's gonna go by operation G, where it's gonna use the existing. Oh, I actually have a A, I actually have a P. Oh, but I don't have a E, but I then create a new path and then call it the E, and then end off with a circle. So for operation G, it's so much so that like first and foremost, I do the operation H of like using the existing sort of alphabet. And for this very case, it's gonna create the using the existing data, the A, P, and then once I don't have like the remaining ones, I then will create a new path. And with this, I create a new path, and then I end off with a circle, which is operation Y. And then I create using the existing data and going a new path, operation I, and end it off with like operation Y to circle it as marking it as like being a word. And if I were to call it, then the pre-established function, this character, it's whatever make it so powerful that pre-established is because of this operation H, where operation H, it just always use the existing data, and it's gonna make things very smooth. H, I feel like is the special feature for prefix tree, if I were to call it. So with that, I use operation G to actually be able to actually insert this whole A. And now we ask that maybe I want to say that is there anything that starts with say B? And obviously like here it's gonna like search through every single item from say like the root over here. It's gonna search all 26 alphabets like A, B, C, D, E, F, G, all the way. Technically, like it's just like a big O of like 26 operations to actually search for whether there's a B, and you can actually find out like whether there's actually a B or not. And in fact, like if it's like saying that it start with like B, you search through 26, it's been short in short form is actually big O of like constant to actually find out whether this thing works or not. So in this way, you're saying that like this operation J, to conduct it in this manner, it's just saying that it's very much efficient in the sense that it just need to constant time to actually find out, rather than sometimes people actually go big O n, sometimes people go big O n square to actually find a word, but this one big O of 1. And if we were to see, is that most of the spells that we actually cast during this episode is very much to do with creating alphabets. You are marking or rather you are like circling end of word. The moment like you are doing these items, these spells at least, it just hints to me that okay, we're actually saying that we're very much using the prefix function, like the prefix tree at least. And the rulebook is very much asking about maybe say like I want to insert a data, I want to maybe say I want to start with a data, I want to check with that, I want to search for data. All this, it just hints that it's time to actually use this prefix, because it's actually able to actually create alphabet from scratch. It's able to mark end of word. It's gonna be able to actually find the start with very much easily in a very fast fashion. And whatever the Leetcode question is asking is also to talk with like efficient. And I mean like this character, obviously you always have the brute force to actually try to actually fight against this main character. And for the brute force, how I actually gonna argue is that operation N. So for operation N is like the brute force way of like doing things, that you start from the root. If it say that please insert a APE, I'm gonna just dilly-dally just create a new path APE as per operation N. Whereas like a prefix tree, what it's gonna do is that it's gonna use the existing data A, P, and then the last one E to actually be able to form with the existing data. So that's how I actually fight against brute force. And obviously we have casted all these spells, and we have accomplished all these Leetcode rulebooks. And obviously like under this whole category is that if only say that I want to form like maybe say a new word, then as you say create APPLE, then I do this operations. But if say that I already have some existing data, then I can conduct these operations over here. Use the existing data, create a new path, and be able to perform my work. So I don't need to waste the extra effort to actually go through the operation end to actually waste the amount of data to actually create a new work. So yep, with that everything comes to an end.